So problem 4 is actually, although it seems like it should be relatively straightforward, it's actually much more complicated. It's actually an extraordinarily challenging question. So the question is, how would you take so this is, if it was just that, it would be toluene. How do you take paramethoxytoluene and convert it to this aromatic aniline? How do you introduce the amine group here? Conversely, how do you introduce this cyanide group here? So introducing these types of functionalities we've seen different places. So introduction of an amine, if we would think about that, the way that we would typically think about doing that is to do an electrophilic aromatic substitution. So we take HNO3 H2SO4. So we would nitrate it. And then we would do something like H2 on palladium, right? Hydrogenate it to the amine. There's a problem here to do that, though, is that this methyl group is ortho-para directing. But this methoxy group is also ortho-para. So this methyl group is ortho. All right, let's go to the one that we should actually be talking about here. This methyl group will direct to the ortho and para positions. This methoxy group will direct to the ortho and para positions. So it's only going to be ortho direction. So the question is, which one is a more powerful directing group? And hopefully you would realize that this is a much more powerful directing group, that the methoxy group is much more powerful than the methyl group. So then if you were to treat this with nitric acid and sulfuric acid, you would predict that you would put a nitro group at this position. So the question is, how do you make this be the main directing group? And this is a very challenging question. And so the first thing that you would do is you would add aluminum trichloride. So what does aluminum trichloride do? Or you could add something like BF3. So both of these are Lewis acids. And when you add these as Lewis acids, they would complex to the free lone pairs here. So we can draw BF3, negative, positive. This is then no longer an ortho-para directing group. This then becomes the only ortho-para directing group. So you would add a Lewis acid followed by HNO3 H2SO4. And then your final step would be hydrogenation, H2 palladium or platinum. Okay. This is a little bit more straightforward. However, I did not talk about it thoroughly, or if at all, in class. And so what you want to do is you want to look at page 597 and 598 in your book, chapter 23, when it deals with diazonium compounds. Okay. So the first step that we're going to take here, so I'll draw this down here. We're going to nitrosylate it. So nitric acid, sulfuric acid. Then we're going to put hydrogen gas and platinum or palladium, whatever you choose to work with at the time. And then you want to treat this with nitrous acid. And there's a very good mechanistic description in your book of what will happen when you treat this with nitrous acid. But the important effect is you get this, which is called a diazonium complex. And what's great about these complexes is that you can then treat these with a whole host of nucleophiles. So, for example, the example that your book uses is that you can treat it with water. Get the phenol out of it. Or in this case, you can treat it with sodium cyanide. And you can think about this complex as this diazonium complex. You can basically think about it like this. Okay, because what happens is that this goes like this, you get nitrogen gas.